Hello again, Algebra 2 class. This set of videos is on Chapter 7, Section 5 from your Algebra 2 textbook. That section is on mutually exclusive and inclusive events. We have three main objectives today. The first is going to be to find the probability of mutually exclusive events. We'll also find the probabilities of inclusive events. And finally, we'll end with another way to analyze some of these scenarios, which is to build a Venn diagram. So this first video is on mutually exclusive events, but before we jump into those, we have to look at a little bit of background vocab. And we've worked with both simple events and compound events leading up to this. We're going to go into a little more detail on what those things are. So a simple event is an event with just a single outcome as your success. So for example, picking a red marble. A red marble is the only way to succeed. Another example of a simple event is rolling an even number. The only way to succeed in that event is to get an even number. A compound event is when there are multiple successful outcomes. So for example, picking a red or green marble is a compound event. Similarly, rolling an even number or a number less than 4 is a compound event because there's multiple ways, there's multiple successful outcomes. And even when you're looking at just compound events, there's also two types of those. The first is a mutually exclusive event. So these are events that cannot both occur in the same trial. So if we go back to that red and green marble thing, you cannot pick a red and a green marble in the same trial. So that is considered a mutually exclusive event. One or the other will happen. Another example is you cannot draw a king and a queen out of a deck of cards. One or the other will happen. With inclusive events, it's a little bit different because these are events where there are shared outcomes, as in there's a little bit of overlap between the outcomes. So for example, rolling an even number or a number less than 4 is an inclusive event. Because if you think about the even numbers, that's 2, 4, and 6, and then numbers less than 4, it'd be 1, 2, and 3, so there's some overlap there. If you roll the 2, it would actually be, it would fit into both of those categories. Another similar example, drawing a king or a club out of a deck of cards. So there is one card in the deck that is both a king and a club. So it fits into both categories again. For now, we're just going to focus on mutually exclusive events, though. This is the formula for finding mutually exclusive events is relatively simple. To find the probability that event A or B will happen, you just add up their two probabilities. Probability of A plus probability of B. Now a reminder, this is a little bit different than our formula we had for independent versus dependent events. This formula deals with when you only have a single trial occurring. So this is only like picking one card, or picking one marble, or rolling the dice once. So let's jump into an example. The bag contains 5 red, 7 green, and 8 yellow marbles. You're going to pick one marble at random. What is the probability that you pick a red or green marble? So first let's think about what makes the events red marble and green marble mutually exclusive. Well, if we think about it, we cannot possibly get both a red marble and a green marble in a single trial. We're only going to get one or the other, and that's exactly what it means for something to be mutually exclusive, right? It is impossible to pick both a red and green marble at the same time. So these are exclusive events. Now when it comes to calculating the probability, that ends up meaning that to find the probability of getting a red marble or a green marble, we just have to find the probability we get a red marble and add that to the probability that we get a green marble. Well, the probability of getting a red marble is 5 out of, let's see, there are 20 total, so 5 out of 20. Plus, the probability of getting a green marble is 7 out of 20. So we add these together, and our total probability for getting a red or green marble becomes 12 out of 20, which we can then simplify to 6 out of 10, or 3/5. Another example. A restaurant is running a promotion where they hand out one ticket with each menu. There is a 1 out of 10 probability to get a free drink ticket and a 1 out of 25 probability to get a free entree ticket. What is the probability that you get a free drink or free entree ticket? So first of all, why are these exclusive events, getting a free drink and a free entree ticket? Again, similar explanation. You only get one ticket, so you can't possibly get both free drink and free entree. There's no overlap between. You get one or the other, which means that we get to use our relatively simple formula. Probability of free drink or free entree is just the probability of getting a free drink plus the probability of getting a free entree, and they told us those numbers directly in the problem. Probability of a free drink is 1 out of 10, plus probability of getting a free entree is 1 out of 25. We do have to get a common denominator here, which we can do as 50. So 1/10 is 5/50ths, and 1/25 is 2/50ths, which gives us a total probability of 7 out of 50 as our probability of getting either of these.